Alright guys, this video is going to be all about statistics, specifically mean, median, mode, and range, alright? So we're going to be working on a group of problems, first from raw data and then from group data. So first of all, what is raw data? Raw data is data presented like this. They just give you a bunch of numbers. It's not organized, it's not put in categories, it's just like this. Sometimes it's all muddled up, sometimes it's put in order, but these are both called raw data. It's just there. It's not on a table or a group or anything like that. Now let's read the first question. Here are 7 cards. Each card has a number on it. 12, 5, 10, 18, 12, 11, 9. Work out the range of the numbers on the cards. Alright, what does the word range mean? Range just means the difference between the highest value and the smallest value. So it's just going to be highest value. I don't have a minus sign. Smallest value. Alright, that's it. The highest value minus the smallest value. So the highest value is 12 minus the smallest value, which is 5. So 12 minus 5 is 7. It just tells us the difference between, if I drew like a little number line, the highest value is 12, the lowest is 5, which tells us the gap between these two numbers, which is 7. Next is the median. The median is the most middle value. The most middle value. Before you do the median, you have to order the data from smallest to biggest or biggest to smallest. Just make sure it's in order first, all right? 5, 9, 10, 11, 12, 12, 18, all right? And we're just going to find the middle value. So what I like to do is I like to cross out either side, so cross out the endpoints, the second most endpoints, and see what's in the middle. Oh, it's just 11. Easy as that, all right? The mean. Another word for mean is the average, okay? How do you find the mean? What you do is just 2 steps. Step 1 is you add values and divide it by the number of values, okay? So step 1 is we're going to add these numbers up. 12 plus 5 plus 10 plus 18 plus 12 plus 11 plus 9. 12 plus 5 plus 10 plus 18 plus 12 plus 11 plus 9. And we're just going to divide all of this by the number of values. So 1, 2, 3, 4, 5, 6, 7, divided by 7. And the answer to this should give us our mean. Let me get my calculator out. 12 plus 5 plus 10 plus 18 plus 12. Oh, let me go one sec. 12 plus 5 plus 10 plus 18 plus 12 plus 11 plus 9. So all this makes 77. 77 divided by 7 is 11. The mean, or the average, is 11. Alright, the mode. The mode's actually the easiest. The mode is simply the most common value. Alright, so what value appears the most in this out of all these cards? Well, the number 12, it's the most common value. There's 2 of them. So the mode is 12. It's the most common value. You can try it. You can try these ones by yourself, alright? If you'd like, pause the video, otherwise we'll do it right now. Work out the range. So range is the highest value minus the lowest value. So the highest value is 14. The lowest value is 1. So 14 minus 1 is 13. Mode. Mode is the most common value. Well, I see, oh, there's 3 11s. So the mode is 11. The median. The median is the most middle value. Before we find the middle value, you must order the numbers. But luckily for us, they're already ordered. So let's just find the middle number. So let's cast out the endpoints. Ding, 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 ding. Oh, there's 2 middle values. If you ever have 2 middle values, all you do is you find the middle of these middle values. So the middle of 6 and 8 is obviously 7. So our median is 7. If you're having a hard time finding the middle point of 2 numbers, in this case it's really obvious. 6 and 8 is 7. If you're having a hard time finding the middle value, what you can do is you can find the mean of these numbers. So you could just do 6 plus 8 And since there are two numbers, you're going to divide by 2. And that will also give you 7. All right? That's another way to find the middle of two numbers. The mean, we have to add the values and divide it by the number of values. So we have to add up all these numbers. So 1 plus 4 plus 4 plus 5 plus 6 plus 8 plus 11 plus 11 plus 11 plus 14. We're going to divide all of that by, how many numbers are there? There's 10 numbers. All right, 1 plus 4, 9, 14, 20, 28, 33, 61. Oh man, I'm just not bothered to add them up. 1 plus 4 plus 4 plus 5 plus 6 plus 8 plus 11 plus 11 plus 11 plus, I was correct. All right, it's 75. 75 divided by 10 is 7.5, and that is our mean. So those are the 4 basic stats you must know, and that's how you find it from raw data. The next stat we got to do is the interquartile range, okay? The interquartile range is kind of similar to the range, whereas the range is we're finding the difference between the highest value and the lowest value, so the difference between these two values. The interquartile range is we're finding the difference between the first quarter value and the third quarter value, and then finding the difference between these two numbers, okay? So let's read through this question. So interquartile range is the difference between the first quarter, which we call the lower quartile, and the third quarter, which we call the upper quartile. So to find the interquartile range, we'll get the interquartile range. It's equal to the upper quartile minus the lower quartile. So upper quartile is 3 quarters, lower quartile is 1 quarter. Let's read this question. A group of 15 businessmen were asked to give a number of different countries they had visited each on business. Here are the results. Work out the interquartile range of the numbers of countries visited. Similar to median, what you have to do is first order them, okay? Now, it's already ordered, that's perfect. Let's find the lower quartile, all right? So the lower quartile is the 1 quarter mark, okay? So there's 15 businessmen. We gotta find 1 quarter of 15. Well, how do you find 1 quarter of 15? We can simply do 15 divided by 4. But the problem is, this won't give us a nice whole number. We're gonna get like 3.75, which we don't really want. I don't wanna look for a 3.75th business person. What we're gonna do is, if you ever have like an odd number of values, just add 1. So we're gonna do 1 quarter of 16 instead. And 1 quarter of 16 is just 4. So the lower quartile is the 4th person. So we're gonna count to the 4th person. 1, 2, 3, 4. The lower quartile is 3. All right. Upper quartile is we're gonna find the 3 quarters person. So we're gonna find 3 quarters of 15. Unfortunately, 3 quarters of 15 will give us a decimal number. So we're gonna do 3 quarters of 16. So how do I find 3 quarters of 16? Well, I can do 16 divided by 4. I split into 4 parts, which gives me 4, and times that by 3, by our numerator, which is 12. So we're gonna look for the 12th person. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The upper quartile is, 1 sec. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our upper quartile is 10 countries. Now to find the interquartile range, all you're gonna do is you're gonna subtract the upper quartile from the lower quartile. So upper quartile is 10, minus 3, which is lower quartile, which is 7. And that's our interquartile range, all right? It's very similar to our range, but the interquartile range is the 3rd quarter minus the 1st quarter. I think I had another question. Here, let's do this question here. Here are the points that Carmelo scored in his last 11 basketball games. These are all his points. Find the interquartile range of these points. So step 1, before you do anything, you must order these points. So 14, 16. Maybe this is about Carmelo Anthony. I hated that guy. He was trash. 21, 22, 23, 23, 24, 24. Make sure I haven't forgotten anything. 11 basketball games, so there should be 11 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Cool. So, interquartile range. Interquartile range is the upper quartile minus the lower quartile. The upper quartile is the third quarter. Lower quartile is the first quarter. So we got to find 1/4 of 11 matches. All right? 1/4 of 11, you'll get a decimal number. So we're just going to add 1. So we're going to find 1/4 of 12 instead. 1/4 of 12 is 3. We're going to find the third match. So 1, 2, 3. The lower quartile is 17. Okay, we'll do the same thing with the upper quartile. So upper quartile, we have to find 3/4 of 11 basketball games. Unfortunately, 3/4 of 11 will give us a decimal number, so we're going to do 3/4 of 12. So 3/4 of 12, so 12 split into 4, which is 3, and then times that by the numerator. So 3 times 3 is 9. We're going to find his 9th game. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 23. So the upper quartile is 23. The lower quartile is 17. To find the interquartile range, we're going to subtract the upper quartile from the lower quartile, which is 6. And that's our answer, 6. Kobe also plays basketball. The median number of points Kobe has scored in his games is 18.5. The interquartile range of these points is 10. Which of Carmelo or Kobe is the more consistent scorer? All right. So let's visualize this by drawing the little number line for both players. So let's call this the Carmelo line, this the Kobe line. Well, let's start with Kobe. So Kobe, his median is 18.5. Median is just the halfway mark. So his most middle game he scored was 18.5 points. And his interquartile range is 10. So the difference between his 1/4 game and his 3/4 game was 10 points. All right? For Carmelo, we know his interquartile range is 6. So 1/4 to 3/4 is 6. And his median, let's find his median. So let's find the middle number. Because we're given the median for Kobe, it just makes sense to find the median for Carmelo. So $21. All right. So let's figure out who is more consistent. Well, basically, Carmelo is more consistent because the gap between his 25th percentile best game and his 75th percentile best game is only 6 points. So the difference between a weak game and a relatively weak game and a relatively strong game is only 6 points. Therefore, Carmelo is more consistent because the gap between a weak game from Kobe and a strong game from Kobe is 10 points. So it's quite a big difference between one of his weaker games and one of his stronger games. Whereas Melo, his gap between a weaker game and a stronger game is only 6 points. So we'll say Carmelo because his interquartile range is less. So the gap between a weaker game and a stronger game is not as big as Kobe's. All right? Because what was Carmelo's lower quartile? Carmelo's lower quartile was 17. So in a weak game, he scored 17, and in a strong game, he scored 23. That's pretty good. Quite a small difference between a weak game and a strong game. Whereas for Kobe, his interquartile range is 10. So we don't know what his lower quartile and upper quartile is. So let's just say it's maybe 10 and 20. So a weak game, he scored 10 points. For a strong game, he scored 20 points. That's quite a big difference. That's not very consistent. Whereas Carmelo is much more consistent because his interquartile range is less. Let's do some problem solving. Here, 6 numbers have a mean of 5. 5 of the numbers are 3, 2, 7, 6, 2. the other number is x. Work out the value x. So there's 5 numbers, and there's a missing number x. And we know the mean of these numbers is 5. All right? So when I do these questions, I think to myself, I'm given the mean. How do I find the mean of numbers? Well, I add up all the values, I divide them by the number of values, and that should give me my mean. So let's just do that. So let's add up all the values. So 3 plus 2 plus 7 plus 6 plus 2 plus x. Divide it by the number of values, 1, 2, 3, 4, 5, 6. Divide by 6. And that gives me my mean. And I know what the mean is. The mean is 5. All right? Then I'm going to simplify the top. 3 plus 2 is 5, plus 7 is 12, plus 6 is 18, plus 2 is 20. So it's just going to be 20 plus x over 6 equals 5. And then I just solve this algebraically. So I get rid of the fraction. Times 6 here, times 6 here. So we're trying to get x by itself. So I'm going to get rid of this 20 and get rid of the 6. X is being added by 20, then divided by 6. So I'll get rid of the 6 first. So that cancels out. So it's going to be 20 plus x equals 30. 20 plus what is 30? X must be 10. And that's our answer. X equals 10. Another way you can solve this is just realizing that how I do this question is that I always realize that if you are given the mean, you can always find the sum of the values. Basically, I have 6 numbers and the mean of these numbers is 5. What you can do to find the total of the values is just do 6 numbers times a mean of 5 is 30. So I know all the numbers must add up to 30. So these numbers already add up to 20, so x must be 10, because 20 plus 10 adds to 30. So whenever you're given the mean, you can always find out what all the values add up to. Next question. A group of students take a test. The group consists of 12 boys and 8 girls. The mean mark for the boys is 18. The mean mark for the girls is 16.5. Calculate the mean mark for the whole group. So we want to find the mean score of the whole group, so including boys and girls. So what I do is I think I'm asked to find the mean. How do I find the mean? We have to add up the values, so sum of values, divided by the number of values, and that will give me my mean. In this case, the values are referring to the marks. So the sum of the marks, so total marks. So instead of sum of values, I'll do total marks number of values. This is just referring to the number of students. So there are 20 students in total. So number of students will give me my average marks. So total marks scored by every student divided by the number of students should give me my mean marks. Well, do I know the top or do I know the bottom? Well, I know for sure that the number of students is 20. 12 boys plus 8 girls is 20 students in total. And now I want to find out the total number of marks scored by everyone, okay? Well, how do I do that? Because all I know is I know that for the boys, there's 12 boys, and the mean is 18. All right. Well, what did I tell you in the last section, guys? If you're ever given the mean, you can always find the sum of values. So since we know there are 12 boys and their mean score is 18, we can find out the total score of all the boys. To do that, we can just do the mean times the 12 boys, which is 216. So in total, the boys scored 216 marks. Because we were given the mean, we could find the total of all the boys. And we can do the same thing for the girls. The girls, there were 8 girls. Each person scored an average of 16.5. So each girl scored approximately 16.5 marks. So there's 8 girls, and each girl scored approximately 16.5 marks, we can just do 8 times 16.5 to find the total number of marks they scored. So 8 times 16.5 is 132. So the total number of marks scored by the girls is 132. So now, to find the total marks for both genders, we can just do 216 plus 132, which is 348. So the total marks scored by everyone is 348. Shared between 20 students, divide by 20, should give us our mean. So 348 divided by 20 is 17.4. And this is the mean mark for all students. Boom. Let's do this last question over here. A, B, C, and D are 4 integers. The mean is 8, the mode is 7, the median is 7.5. Find the value of the largest of the 4 integers. First of all, the word integer means a whole number, alright? Positive or negative. So I have 4 integers. I'm going to draw this out. So we have 4 numbers, 1, 2, 3, 4, A, B, C, D. We know that the mean is 8, so mean is 8. Oh, look at this. So basically, remember, if we're given the mean, and we know the number of values, to find the total of what all the values add up to, we can just do 8 times 4. The mean of 8 times 4 values is 32. So we know all these numbers must total to 32. So that's the clue we get for our mean. Next, the mode is 7. So mode means the most common. So the most common value is 7. That's our second clue, that our numbers first must add to 32. The most common value is 7, and the median is 7.5. The middle number is 7.5. Well, the middle is boom, 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 boom. It's basically here. It's the middle is 7.5. So now we have to find the value of the largest 4 integers. Well, let's start with the median. So we know that if the middle is 7.5, these two numbers must have a midpoint of 7.5. So why don't we do 7 and 8, because the middle of 7 and 8 is 7.5. Next, I know the most common value is 7. So we must have at least 2 7s. So let's say 7 is here. And we know the numbers must total to 32, because we were given the mean. If we're given the mean, we can find out what the numbers add up to always by doing the mean times the number of values. So we must add up to 32. So 7 plus 7 is 14. 14 plus 8 is 22. 22 plus 10 is 32. So the largest value is 10. All right. Next, find the mean value of the numbers 2a minus 3, 2b minus 3, 2c minus 3, and 2d minus 3. All right. Well, let's have a look. Well, I guess we're using our a, b, c, and d from here. So let's just find the value of each of these. So 2a minus 3. So 2 times a is 14, because a is 7. So 2 times 7 is 14, minus 3 is 11. 2 times b, well, b is 7. So 2 times 7 is 14, minus 3 is 11 again. 2 times c, 2 times 8 is 16, minus 3 is 13. 2 times d is 20, minus 3 is 17. Now we have to find the mean. To find the mean, you add up all the values and divide them by the number of values. So we have 4 values. 11 plus 11 plus 13 plus 17. Well, this is 30 plus 22 is 52. 52 divided by 4 is 13. And that is the mean of these values, okay? And that's how you solve this problem. So you're given these clues. The mean is 8, so all the numbers must add up to 32, because 8 times 4 is 32. The mode is 7. There must be at least 2 7s. It has to be the most common value. And the middle has to be 7.5. Once you have those 3 clues, it's really easy to know what to do.